Hi, in this video, we're going to be delving a little bit deeper into the code base, specifically surrounding the getting started optimization or the optimization stuff. Now, hopefully you would have already watched the initial video, and that was just explaining the installation and running your first or the default optimization. Now, one thing I just want to add for that is, if you've downloaded the code for the first time, you still need to compile it first. So what do I mean by that? Well, inside your code, what am I doing? Inside your code, in like the root folder for the code base, so you should be able to see stuff like this, where it's like all the different folders and everything nice. You need to type cmake space dot. This will generate like the cmake files and all the compilation files. Just like it is explained in the getting started with the installation, like the default installation. Yeah, it's exact same stuff. And then you'll type make. Now mine's already been built, but yours might take a few moments and then go through a whole building process, like you can see here. Yeah, so that was one additional thing, just to make sure you're aware of that. So if we go back into our optimization kick folder, then the idea from the last video was to run this run.sh. So it's going to start running and doing some stuff in the background. Cool. So what you're actually doing. So if we go into the manual, we can go to the code base explanation. And I'm just going to walk you through briefly each of the elements in it, and then the workflow, or how like this optimization process gets carried out. So like I showed in the first video, there are three basic components to this optimization problem. There is the optimizer, and this is basically the algorithm we use to try and optimize something. All right, and the something that we're trying to optimize are our parameter files. And I describe the parameter files as being basically numbers that are associated with features or variables that we need to try and like optimize for. Now, what do I mean by that? Well, we need to try to find the optimum collection of values for these parameters so that we can perform better at some task. This task being the optimization task. So the optimizer basically optimizes the values in the parameter file for a given optimization task. And these tasks are to do with the skills that we can perform, which are walking, kicking, getting up, stuff like that. Cool. So once again, inside the little code base explanation, you can see I go into a lot more detail what the parameter files are. Some important files and folders. So here, our default parameter files our default parameter file will look something like this with a few more things. But here you can see those variables with their associated value. And through the processing of our optimization, these will get loaded and updated and stuff like that. Now, there is a very important file called sample start optimization, which actually came default with the code base. And this file basically is what runs the server as well as the visualizer and the agent to perform a particular task. So when I go through the workflow, you'll be able to see how this comes into a little bit, how it's utilized a little bit better, as well as these other files. The other thing I just want to speak about is an individual. So this is a class object, and the individual basically represents like a current state of our parameter files that we want to optimize for. So the individual is defined in the individual class, and it's just made up of an array of values that correspond to an array of labels or features. In other words, like an array of these, like kick, weight, scale, offsets, all of those. Cool. Now, depending on your optimization algorithm, what you basically want to be doing is, you know, mutating or changing this individual over time to hopefully become better and better at performing a given task. All right. Now, the optim method class is basically what we use, or class structure that we use to define the algorithm for our optimizer. So it's made up of a couple different things. There's like an initializer function, an optimize method, which is what we use to like pick the better parameter values. A run method, which basically runs our, well, I'll explain that in a few moments, so don't dwell on that one too much. A method called getFitness, which basically tells us how good an individual is, or how good a set of parameter values are at performing a given task, and a few other ones. So here you can see an example of one of these optim methods, but it's also in the code base. So if we go to the code, if I go to optim method, I think I have it open already. Do I? Perhaps not, but maybe it's best if I just show you where it is. So inside Kick, open the folder, and there is an optim method py file. And that's where you can see all that stuff defined. Now there is a little README here that you can read as well, and that explains some of the stuff as well. So there's lots of help for you guys available. Okay, where were we? Cool, so that's that. Now, in terms of the workflow, so this workflow section basically explains, like, when you say run.sh, what are you actually doing? So what's happening behind the scenes? And then this will be useful for you guys, because then you can use this, or once you understand this, you can actually understand how to, you know, do a few other things that are more in line with what you want to do. Like maybe the different things you want to optimize, or the different algorithms you want to implement to do your optimization with. So the first step is that you run the run.sh file, right? And that's what we did. So if I go back into the code here, we ran this file, right? And all this does is basically run the run optimization.py file. It does some correcting of some paths and stuff like that, but this is how it works. So it basically comes in here and then runs run optimization, which is this file. So I just opened that, and if we go back to the workflow, it says, well, this runs, you know, run optimization. And inside run optimization, it says that this initializes our defined optim method and it loads our initial parameter file. So we just check that in the code. Where am I doing that? So if main, then main must be run, or the main method must be run with this. So you can see here we're loading in, or we're selecting the initial parameter file that we want to optimize over or from. Now you can change this path to be whatever you want. Maybe you want to optimize with a different file or something like that, then just change the name or the directory here. Or put it in this folder, and yeah, but that's basically what you do. And then this runs this, right? This whole chunk here. Cool. So what it basically is doing is initializing, well, the beginning of it is initializing our objects. So it gets our first individual, our starting individual, from that file, from that parameter file. So if I go to that parameter file, which is in the parameter files folder, I just need to find that. Here it is. And you can see there's quite a few different files that, you know, there's just like the files we've created over time and we've been picking up. So there's quite a few different ones. So this is new params _0 _kick. So it's this one. So if I open that, you can see these are the parameters that are going to be loaded in as our starting individual. So the one array is going to be this list of like variable names, and then the other array is going to be the actual values. And that is what this guy's doing basically. Now the next one is saying optim algo to use, and this is basically defining our algorithm class or our optim method class that we want to use to optimize these variables. So here we can see that we're using the simulated annealing example, and then this takes in a few different things. the starting individual, the labels associated with that starting individual, a unique identifier just to like name this experiment, as well as a task. This is the particular task that you want to optimize for. So before I get into like how this changes or how you can change this and do stuff, we're going to go a little bit deeper and then I'll come back to that. But you can also see commented out here is this algo to use random search, which has exactly the same structure because it's inheriting from the same optim method class. So these are all defined in our examples folder over here. So inside Kick, there's an examples folder and you can see a do nothing. And you can see this do nothing class basically extends the optim method class. Same with random search and simulated annealing. Cool. So once again, these extend our optim method class. Well, let me just check. I don't want to get ahead of what's in the notes. So let's just go back there. Oh, okay, so another thing to understand is that during this initialization, a config runner is set up. So where is the config runner set up? So where were we? We were on run optimization.py. Yeah, so we define that that algorithm to use. We define the number of steps that we want to run for, and we also then, perform said optimization. So if we go into this simulated annealing class, we can see that it overloads the initiate method, the initialization method, the run method, and then there is additional should swap. So this is just a method specific to this approach. But because this extends the optim method class, we can also, make use of the parent class's attributes. So inside that, there is an initiate, all right? And inside that, there's a config runner that gets initialized. Now this config runner is important because this basically stores the config of how you want to run the RoboCup server, which RoboCup agent you want to run, and if you want to run like the visualizer. And this will become important for the next method. So inside here, you can see an optimize method, all right? And that's that same optimize method that we are referring to in run optimization. So we initialize the algorithm we want to use. We define how many steps we want it to run for. And then we say, okay, well, we actually want to do the optimization. So our final individual and our final score will equal the algorithm.optimize method. So if we go back to that algorithm, the simulated annealing, it doesn't overload the optimize, which you don't have to, which is nice. You can see the optimize method has that function already defined. And then even in here, we say, run this when doing optimization. Yeah, and you don't have to change that. However, the run method is something that you do need to implement for your own different approaches. So that's why this is like kind of left blank here in the root class or the parent class. And then inside SA, which is like the child class, you can see the run method is defined. Okay. So this run method is kind of like your training loop, if you want to think of it like that. Yeah. And that takes in like the number of steps that you want to train for and runs, a loop, which makes sense. However, what it does is it says self.initiateX, so it initializes the current individual and it gets the current score. Okay. And how we get the score of the current agent is while we run the server and we run an agent, and the agent needs to perform a task, and how well the agent performs at said task is the fitness for that agent. So if you want to think of it, so fitness is more of like a genetic algorithm term. If you want to think of it more as a reinforcement learning term, then like this is how you get the reward. So the agent would perform a task and then they would get a reward. So let's have a look a little bit more in detail about this get fitness, because it's very important. So you can see this algorithm class that we extended doesn't actually implement get fitness. And when you want to make your own ones, you also don't have to implement it. As you can see, it's already been done in this root or parent class called Optimethod. And here you can see it says get fitness, takes in an individual, and now we have to get that fitness. So how it works is it creates a process using the config runner's like information to run the RoboCup like domain. Okay, so there's quite a few things to understand here. But most importantly, you can see there's this config runner.run RoboCup. And again, this stuff is implemented so you don't have to. All you need to do is call the get fitness class, but I'm explaining it so you have a better understanding. Okay, so if we go to the config runner class, which I have open, but you can see it's in this utils PyCache folder. So in library or lib, in utils, in PyCache, there's a config runner. Well, no, not in PyCache, sorry, just in utils. There's a config runner py class, and that basically has the run RoboCup method, okay, which is what we want to know about. And this basically makes a thread or a sub-process that runs sample start optimization. So you can see there's a lot of things that run something that then run another thing. I get it. It's confusing, but once you get the hang of it and really like understand the pipeline or the process, you'll have a better understanding as well. Or it won't seem so daunting at least. Cool. So this runs our sample start optimization.sh. Okay. And it sends through a couple parameters, like where do we want to store our output parameter values? Well, in this text file, defined like this. And it also tells us what task we want to run. Okay, and I'll get back to the task. I know I've spoken about the task, but I haven't, explained it. So you can see here the optimization task is also sent to this this like sample start.sh file. Cool. So basically what happens is, get fitness creates a process. That process then runs this RoboCup function, and this run RoboCup function basically creates the experiment where the agent can perform a task using the RoboCup server and do some stuff. Cool. So let's have a look at sample start. And sample start is over here. And it has a lot of information, very overwhelming. I get it. But all you need to know is that what it does is it runs this line at the bottom here. And what that's doing is it's starting the server, it's loading an agent into the server, and if you want, you can tell it to also start the visualizer. So how do we start the visualizer? Well, there's a little if statement here that will run the visualizer if this doVis variable is true. So here, what you could do is you could just set this to be true, and it would run the visualizer as well. Cool. So if I just go back to the notes quick, how far ahead did we jump? So the config runner, which contains a function called run RoboCup, which is actually used to set up and run the RoboCup environment, which can obtain fitness information from, is initialized. Okay, then inside run optimization py, we call optimize. This method called run, which is found in the base of Optimethod. Inside run, we call get fitness on a current individual, after which we enter training loops, which can be seen there. Cool. Okay, so if we step back out a couple steps, so we inside SA, and you can see we run, and then we got the get fitness, right? And then we run our training loops. There's another get fitness which will then repeat that same process of, what was the same process inside Optimethod, which will run Robocop, which will run the sample start.sh, which will then finally return a fitness. So then this will like loop and do things. Now what is in your hands, or what is up to you, is say we have a set of values, a set of parameter files, we get the fitness. Say these 10 values resulted in a fitness of 5. Okay. It's your job to figure out like, how do we change those values, right? In which way do we tweak them so that we can get like a different result and hopefully a better result? Well, for that, I mean, you should do your own research, but there's a couple different approaches. And specifically for like this genetic approach that we demonstrate here, you basically take that individual, you slightly mutate it in a way, like you change the parameter values a little bit here and there, and then you get a new fitness. And if it's better, well, that's great. You keep that, and you use like a population-based approach like that. Yeah. So look up genetic algorithms to understand a little bit better how they work. But that was like the one implementation we've demonstrated here. Cool. So this will run until you tell it to stop. Until like the number of iterations are finished and stuff like that. But the last part that I just want to touch on is like what actually happens when we try get that that fitness. So once again, I'm repeating myself just so you understand. Like the get fitness function is defined in Optimethod, which creates a process which runs the run Robocop method found in the config runner, which runs the sample start optimization, which starts a server, creates an agent, and tells that agent what to do. Okay, so we in our task here, if I go to the very beginning of my talk here inside run optimization, we define a task name as kick score. So we're trying to optimize a set of parameter values performing the task kick score. And this task gets funneled all the way, this like label name gets funneled all the way down through our config runner, whereabouts over here. It gets funneled down into our sample start optimization, all the way to this. So this would be that kickstart. And then when our server is created, when our agent is created, they start running the main code, right? So they have that, they run the main method, just like your normal agents run the main code, and then eventually it will get into that select skill function, right? So when that method is run, when the sample start optimization or sample start optimization.sh file is run, well, these things are all set up and they get going. So what ends up happening is you come into the main method and you go into the run behavior or run method, and where we actually create our agents, you can see there's quite a few of these if statements, right? Like now agent, goalie, all these things. Now defaulted in when you're just running the normal agents, playing soccer and stuff like that, it would just be like a now agent. But there's all these additional ones like fixed kick agent and all of these. And these are the agents that are for our particular tasks. So you can see here kick score. So because we filtered that task through all the way down to the sample start optimization, the agent that we create will be the kick score agent. And this has this very specific behavior. And this behavior is defined by optimization behavior kick score, right? Whereas traditionally it's just defined as by a now behavior. So let's have a look at this like behavior. So that's in optimization behavior kick score, which can be found in optimization behaviors. Okay, so there's quite a few that we've defined, and these are the behaviors that you'll use as your like optimization tasks. So here's kick score, all right, and kick score has a very well-defined structure that is common across all the different optimization tasks, and that structure involves having some common functions. Firstly, a constructor, which makes sense, a beam function, a select skill, and an update fitness. Now the beam function, just like in the base code, is used to place the agent initially. The select skill function is used to define, the actual behavior of the agent, like where they should walk to, when they should kick, all of those things, exactly like how it works normally. And now our update fitness is basically a method that needs to keep track of how well we're doing while performing some behavior. So this is the header file, and of course the header file has a CC file, which actually defines, the stuff. So here we can see that we have our beam, and we're placing our agents a little bit left of the starting like middle line or middle point. All right, you don't have to really think about the check beam too much. Then there is a select skill. And for this kick score function, what we wanted the agents to do was walk to the ball and then kick it into the goal. So what we have is, and then once he scored, to stop. Yeah. So what we have here is that, there's a couple different initialization things. Like if the agent is, if the time is less than 0, so maybe before the game started, then the agent should just stand, and we initialize this kick function. And this initiate kick basically just like initializes the kicking experiment. So you can read up on what it does. Then we wait like a small initialization time, and then while it's doing that, we also just want to stand. And then if we haven't scored, so this is like has scored variable, then I want to return kickball into the goal, which is just this kickball function. And then at some point when we have scored, then I just want to stand. All right, so that's like the behavior we want the agent to exhibit. You can check in some of the other ones, like the walking tasks. The walk forward task is near the top, I think. Fixed kick. No. Walk forward task has its own select skill behavior. And that behavior was simply just to go to the target, list this particular target. So, we want to optimize maybe our walking speed in a straight line. Well, then let's just tell the agent to walk in a straight line. Hopefully that makes sense. Okay, back to the kick score one though. So then additionally we have the update fitness. So what's important to note though is that in order to minimize the variance in our experiments, we run multiple and then average them. Now this is because it's the agent has imperfect information. And they might fall over, but they fall over once out of 10 times, and they do really well the other 9 times. So the score could be still really pretty good. So what we do is we run this optimization task 10 times, or in this case 5 times, defined by this kick equals 5, and then we take the average fitness over those times. So in order to do that, we need to keep track of the fitness while we play in the game. So initially, like, the fitness would be 0, and then based on a few conditions, it could be more or less. So if we go down to some of them, So if for some reason like the agent fails like a beam check, which means like they've kind of died in some way, we want to decrease the fitness by 100. Another time when the agent takes too long to score a goal, then we also want to punish the agent by decreasing the fitness by 100. But if the agent does kick the ball, we want to increase the fitness. So like if we take the distance the ball's traveled, we want to add that to our total fitness. So for this kick task, our fitness is based on how far the ball travels from its starting point. Yeah, cool. And then you get a better score if you score as well. So you get a better fitness if you score the ball in the goal, which can be seen here. Cool. So that's kind of how the tasks are working. So if you wanted to make your own one, then you would come into like these files. Look at the structure, and make your own one. Give it its own name and everything like that. And then you would go into the main method. You would add to this else if. You would put the particular task tag here. Maybe you called it my task. And then when you want to actually perform or run optimization on that task, you would go into your run optimization.py and then change this to that task where it says task name. And that will do it. Cool. So I hope you understand a bit better. But so before I conclude though, let me just go back to the notes quick and just double check I've touched on everything. So you get the fitness, which runs run Robocup. Inside run Robocup, we run the sample start.sh. Inside sample start.sh, it actually starts the server and stuff like that. You can set the visualize the tag to be true, all good stuff. We load the desired agent with the parameter files that we stipulated in that initial component with the particular task. The agent's main loop will begin executing, which runs the beam function. Runs the start.sh. Well, it would be the same as if we run start.sh, which then does the beam function. Cool. I think I have covered everything. Oh, and then once that optimization, all those like 10 tasks or 5 tasks is being completed, we then write that fitness to an output file. All right. The game loop will then end, which will exit from process P. So we go back to process P here. Not here, inside SA. Inside get fitness, so that's inside the Optim method. So that will close this, that will like complete this part. Okay, and then afterwards we will read the output from the file, basically to get the fitness value. So the reason we do this is there's no way of sending like, or maybe there's a way, but we don't know, of returning the fitness directly from the process. So we just save the fitness value to a file and then read it later when we want to get the desired output back. So this will then get the fitness value from the file, designated by like this string, or by this name. That will return the fitness. That returns the fitness back over here, over here and here every time it's called. And then now you have that like individual and fitness pair, of which you can do some optimization or you can make some changes. Cool. So that's basically everything. I highly recommend, obviously, just looking at what we have implemented, like realizing that you don't have to make many changes. You know, it's basically you have to implement your own class that looks kind of similar to simulated annealing example, or your own class that looks similar to random search, and then hit play basically, and it will do the rest. All right. Finally, I just double check that is everything. Cool. There's more about like explanations on the example optimizations here. There is explanations, a little bit of explanation on creating your own optimizations. Some explanations on creating your own optimization tasks. Yeah. So feel free to look at this, ask questions on the Discord, and reach out to us.